Hello class 12 students, Aggarwal students, welcome once again to Maths is Possible. I am going to continue your video for the chapter Continuity and Differentiability. So I have done till question number 30. Let's continue with question number 14. Okay, these are again important type of a question. Okay, this is important. Question number 14 says f of x is defined as mod x minus 1, mod x minus 1, and you have to check continuous is examine. Question, the heading is examine. Examine if continuous. Examine if continuous at the indicated points. Okay, so you have to check, this was the heading, so you have to check this if it is continuous at x equal to 1. Okay, so let's begin. So this is a modulus function. You have learned that any number inside the mod sign, even if it's negative, it comes out as a positive. Okay, so this function, if you write it, it will come out as a positive, x minus 1. Alright, now we have to check the continuity of this function at that indicated point. So LHL, left hand limit. So limit, now you will use this limit of x tends to 1 negative, f of x is equal to limit of x tends to 1 negative, x minus 1. Now when you put 1 here, you're going to get a 0, right? 1 minus 1, 0. Don't put minus 1. I already told you why. Check my previous videos. Okay, RHL, limit of x tends to 1 plus f of x is equal to limit of x tends to 1 plus x minus 1, that is 0, and f of 1, you again have to put 1 here only. So 1 minus 1, that is 0. All three things are equal to each other. LHL is equal to RHL is equal to f of 1, which is equal to 0. So the function is continuous. Okay, so f is continuous at x equal to 1. Okay, so let me check the answer for you. Let me see if it's yes or no. Okay, I know it is yes. Question number 14, yes. So this question is continuous. Let's go on to the next question. Question number 15. This is important because it might come, okay, for your exam. One mod type they want to give, an easy one maybe. Okay, let's go on to the other one. This is also the mod type 15, same heading, examine if continuous at the indicated points. So f of x is given as x minus mod x. Alright, x minus mod x, and you have to check if this is continuous at x equal to 0. So first you have to write the function. So write the function, that is f of x is equal to x minus x. You want to go ahead and write a 0, don't write. Just write this. This is your function. That's how it's supposed to come out. That is a mod x. It will come out as a positive. So it will come out, it will be x. Now start your LHL. Don't solve that. Leave it like that only. So limit of x tends to 0 negative, f of x is equal to limit of x tends to 0 negative, x minus x, that is 0. Okay, put 0 minus 0 is 0 only. RHL, limit x tends to 0 positive, f of x, right hand limit, okay, limit of x tends to 0 positive, x minus x, that is again 0. Then f of 0 is 0 minus 0 is equal to 0. So all three are equal to each other, hence the function is continuous. So LHL equal to RHL equal to f of 0 is equal to 0. So f is continuous at x equal to 0. Okay, so that's it for this question also. It's done. Left for me to check the answer. Question number 15, it says yes. So I have done 14 and 15. Let's tick them off. 14 and 15. So question number 14 is done. Question number 15 is done. Let's go on to question number 16. Okay. So question number 16 will be, let me see, will be important. Okay. Question number 16. Important question. It says examine the following function for continuity at the indicated point. Okay, same thing. The function is given, mark important, 3 stars. F of x is equal to x square and minus x square. X square when x is greater than equal to, okay, greater than equal to 0, and minus x square when x is less than 0. Okay, and you have to check at x equal to 0. You have to check whether the function is continuous at x equal to 0. So start. LHL, left hand limit x tends to 0 negative, f of x is equal to limit of x tends to 0 negative. So negative less than 0, you will use this one. So that is minus x square. So you put a 0. When you put a 0, you will get minus. Nobody writes, you don't get a minus 0, okay? It's always a 0 only, even though it's coming up minus 0. So RHL, right hand limit of x tends to 0 positive, f of x is equal to limit of x tends to 0 plus x square you are going to take, right? You are going to take the x square value greater than 0. See, approaching 0 from the positive side means greater than 0. Approaching 0 from the negative side means less than 0. So these two are done. Now f of 0 at equal to 0, you are going to take x square, which will give you 0. So all of them are equal to each other. LHL equal to RHL is equal to f of 0, which is equal to 0. So yes, continuous. Okay, you don't write yes, you write the function is continuous. Okay, that's part 1. Let me check the answer of part 1. 16 part 1. Continuous. Okay, this is 16 part 1. Important question. Let's go on to 16 part 2. Okay, that's also important. 16 part 2. Part 2. F of x is equal to, same heading, five x minus 4 and 4x square minus 3x. If x is less than 1 and this part if x is greater than or equal to 1. Okay, and you have to check whether it is continuous at x equal to 1. So let's start with the left hand and right hand limit. LHL, left hand limit x tends to 1 negative, f of x is equal to limit of x tends to 1 negative. Which function you will take? 1 negative means approaching 1 from the negative side. That means what? It means it's less than 1. Approaching 1 from the negative side means less than 1, maybe 0. Okay. So you will take 5x minus 4, but you will put the value of 1 only. So 5 into 1 is 5 minus 4. Answer is 1. Let's go on to the right hand limit. Okay. So limit of x tends to 1 plus f of x is equal to limit of x tends to 1 plus, now greater than 1. See, greater than 1 is here. So you will take this function. So now 4x square minus 3x. Now put the value of 1. You put 1 over here, it's 4. You put 1 over here, it's 3. So 4 minus 3 is 1. Now next you have to put f of 1. So f of 1 equal to 1 also, this function. So 4 into 1 minus 3 into 1, answer is 1. So you can see all of them, the answer is 1 only. So the function is continuous. So I am just writing it yes. You will write the whole thing. Okay. You will write the whole thing. Let's go on to question number 17. 16 part 1 and 2 is also done. Going on to question number 17. Question number 17 says, is the function f defined this continuous at x equal to 0? What about its continuity at 1 and 2? Okay, let's write the question because otherwise you will not understand. It says that there is a function that is given. It's given as f of x is equal to 2x square, yes, 2x square minus 3 and 5 over here if x is less than equal to 1, less than equal to 1, and if x is greater than 1. You have to check whether this function is continuous at x equal to 0. Something different. Okay, not the number that is given over here. You have to check whether the function is continuous at x equal to 0. And they are also telling you what about at x equal to 1 and 2. At x equal to 1 and 2. First 1, then 2. Okay. So they are asking you to check whether the function is continuous at x equal to 0. And they are also telling you to check what about it when the function is at x equal to 1 and 2, what happens? Is it continuous at x equal to 1 and 2? They are wanting you to check at 1 and 2 also. First let's check at x equal to 0. So write at x equal to 0. This is your first part, okay, at x equal to 0. So LHL, limit x tends to 0 negative, f of x. You see 0 negative means approaching 0 from the negative side. If it's approaching 0, if the graph is approaching, this is 0, okay, this is 1 here. If the graph is approaching 0 from the negative side, okay, from the negative side, that means it is still less than 1. 1 is here, it's still less than 1. So you will use this function. So limit of, see, less than 1, x tends to 0 negative, 2x square minus 3. Put a 0, you get minus 3. Now let's check at positive. Then RHL, limit x tends to 0 positive, f of x is equal to limit x tends to 0 positive. Now which function will we use? Now you see, it's approaching 0 from the positive side. So it will be somewhere over here, say 0.7 or something like that. No, not 0.7, say 0.5 or something like that. Whatever. Okay. If it's approaching from the negative side, let's make it a little different. Okay. Little bit more spacing required. Okay. This is 0, say, and say the here 1 is here. So the graph is approaching 0 from the negative side, from the positive side. So say it's here somewhere. So this point, say it's say 0.8 or something like that. So it's still less than 1. Okay, so you're going to use this value only. So you're going to use 2x square minus 3 is equal to minus 3. It's still less than 1. It's approaching 0. Okay, it's still less than 1. Alright. Then f of 0. So f of 0 is of course less than 1. So we'll use that value only. So 2 into 0 minus 3, that is minus 3. So f is continuous at x equal to 0. Now let me just check this answer for you. This is the first part, 17's first part. First part, it says yes, it's continuous at x equal to 0. Now let us check at x equal to 1 and at x equal to 2. So let's rub out this graph. Now we'll check at x equal to 1 and 2. Okay. Let's start at x equal to 1. Okay. So LHL, left hand limit of x tends to 1 negative, f of x is equal to limit of x tends to 1 negative. Which one? Which one we will use? Tell me. Less than 1. So that function, that is 2x square minus 3. So put a 1 over here. So 1 when you put over here, that is 2 minus 3 is minus 1. Then the right hand limit. Okay. So limit of x tends to 1 positive, f of x is equal to limit of x tends to 1 positive. Now which one you will take? Tell me. Now it's approaching 1 from the positive side. Let's draw the graph again. Okay. So now we are interested in 1. So the graph is actually coming to 1. When it's coming to 1 from the negative side, so it's less than 1. But when it's coming to 1 from the positive side, okay, it's greater than 1. See? It's greater than 1. So when it's greater than 1, then you have to take 5, which will be equal to 5. Now you see these two things are not matching. Okay. So limit x tends to 1 negative, f of x is not equal to limit x tends to 1 positive, f of x. So f is not continuous at x equal to 1. So f is not continuous at x equal to 1, discontinuous. Let's check at x equal to 1. Then it says 5.1, where is it? X at x equal to 1, discontinuous, it says. So at x equal to 1, you can see it's discontinuous. You don't have to go and find f of 1 because there is no use. You can already see that the LHL and RHL are having two different values, right? LHL and RHL are having two different values. Once you get these two as two different values, you don't have to do the third step to find f of 1. This way it proves that they are not continuous. Let's go on to the second one, the next point, the third point. This was part 2. Mark it part 2. Let's go on to the third point. Okay, at x equal to 2. At x equal to 2. Okay, so LHL, then again left hand limit. So limit x tends to 2 negative, left hand limit, f of x is equal to limit of x tends to 2 negative. Always understand with a graph, otherwise you won't understand. Just draw a graph. 1, 2 here, 1 here, 2 here. This is a 0. Now look, it's approaching 2 from the negative side. If the graph approaches 2 from the negative side, it's still greater than 1. Say somewhere over here, say 1.7, still greater than 1, right? Which one? 5. So this is 5 will be equal to 5. RHL, right hand limit. Limit x tends to 2 positive, f of x. Limit x tends to 2 positive, approaching 2 from the right hand side. Somewhere over here says 2.1, still greater than 1. So 5 again. 5. Okay. Now f of 1, at f of 1, now look at this, no, not f of 1, f of 2. F of 2. Now we are checking f of 2. So at f of 2, that's greater than 1. Okay. So of course there is no 2 point over there, but it's greater than 1 means you will take 5. So there you go. All 3 points are same. All 3 values are coming same. LHL, RHL and f of 2 is coming same. So yes, the answer is yes. So the function is continuous at x equal to 2. It's discontinuous at x equal to 1, and it is also continuous at x equal to 0. So you saw, very nice question, and this question you can mark important, will come for your exam. Something like this will come for your exam if it comes for at least 4 marks. Okay, so you can mark this question, class 12 students, ISC students, mark this question, important. Okay, let's go on to 18 part 1 and 2, and we'll do question number 19 part 1, and we'll finish it off for this video. It says examine the following functions for continuity. Same thing, examine for continuity. Okay, 18 is an important question, please mark. This is an important question. Part 1. It's given as f of x is equal to x divided by mod x when x is equal to not equal to 0, sorry, and it is going to be 0 when x is equal to 0. You have to check whether the function is continuous at x equal to 0. Now, first of all, this part will be solved, and what this function will be, it will be f of x will become now x by x when not equal to 0. Don't solve that x by x, not now, not as of now, don't do that. Okay, let's start with the LHL, the left hand limit. So limit of x tends to 0 negative, f of x is equal to limit of x tends to 0 negative. So 0 negative means not equal to 0. So not equal to 0 means x by x, cancel the x and x, answer is 1. Don't put 0, because as you put 0 you get a 0 in the denominator. Over here you are supposed to cancel the x by x. Put that function and cancel x by x. Then RHL, very simple question actually. Okay, again limit of x tends to 0 positive, f of x is equal to limit x tends to 0 positive, again x by x. Why? Because x tends to 0 positive, means not equal to 0. Answer is again 1. Okay. Answer is 1. Then f of 0, when you have equal to 0, the answer is what? At x equal to 0, you see the answer is coming as 0. So finally what can you say? The function f is not continuous continuous at x equal to 0. Why? Because LHL equal to RHL, which is not equal to f of 0. We are supposed to check at 0, okay? Because at 0, you're getting the answer as 0. But when you're taking not equal to 0 or approaching 0, then you're getting 1 and 1. So let's check this. It just says examine the function for continuity. 18 part 1. Okay. Question number 18 part 1, discontinuous. Okay. This is discontinuous, not continuous at x equal to 0. Let's go on to 18 part 2. 18 part 2, again important question. Okay. Sometimes some of you will get confused because there is a mod over there. Okay, but there is nothing to get confused about. The mod just comes out as a positive and then you solve it like a normal function. Okay. 18 part 2. F of x is equal to x minus 4 divided by 2 mod x minus 4. That's a mod x minus 4. Okay, when x is not equal to 4, okay, and 0 when x is equal to 4. And you have to of course check at x equal to 4. So finally in the rough, this function will actually become this way, that is x minus 4 divided by 2x minus 4. You might want to cancel, don't do that. Okay, I told you many times, don't cancel it. Because it came out of the mod sign and then the function is like this only. Okay, now let's start with the LHL, left hand limit. LHL. Okay, so limit of x tends to 4 negative, f of x is equal to limit x tends to 4 negative. Which one are you going to take? So not equal to 4. So you're going to write x minus 4 divided by 2 x minus 4. Please don't put the 4 inside. Your cancellation has to be done here. Cancel. Answer is 1 by 2. Okay. Some of you may be thinking, why can't I cancel there and then write 1 by 2? You can go ahead if you want to do that, do it. Okay, no problem. That is also correct. Okay. Limit of x tends to 4 plus f of x is equal to limit x tends to 4 plus x minus 4 divided by 2 x minus 4. Cancel these two. Answer is 1 by 2. Now f of 4 is giving you what? 0. So is it continuous? No, it's not. Discontinuous. Discontinuous. Let's check 18 part 2. Question number 18 part 2, discontinuous. Correct answers. All correct answers are coming out. Let's go on to question number 19 part 1. Finish it off for this video. Alright. And then we will continue this in the next videos. Many questions done today. Okay. Question number 19, it says examine the following functions for continuity. Similar type of questions are coming. Okay. But this has got a 3x, so I want to do this or this. Okay. So this is question number 19. Okay. Part 1. Question number 19, part 1 is given as f of x. You have done a question like this, so nothing to worry about. 3x. Alright. When x is equal to not equal to 0, not equal to 0, and 3 when x is equal to 0. Okay, and you have to check whether it's continuous at x equal to 0. You have to check whether it's continuous at x equal to 0. Simple. Start with the LHL. Okay, so limit x tends to 0 negative, f of x is equal to limit x tends to 0 negative. Function you have to take is x by sine 3x, because that's not equal to 0. Now from here, you know your class 11, you have to divide this by 3x, then you have to divide that also by 3x. Okay, so divide this by 3x. Look, let's do that in the rough. Let's do that in one more line. Okay, let's do that over here. Let's do one more step and do that. So 0 tends to f of x is equal to limit x tends to 0. Okay, see, x by x, okay, whole thing divided by sine, okay, 3x, divide by 3x into 3. See, look very carefully what I did. X by x, okay, divide by 3x into 3. Why? Now look, when you do this in the rough, go to your rough and write it again. X by x, divide by 3 dot sine 3x divided by 3x. See, cancel 3x, cancel x. What are you left with? You're left with x divided by 3x, right? Comes back to the question. See, comes back to the question. Now in class 11 you have studied limit of x tends to 0, sine x by x is equal to 1. So if you have 3x, then if you put limit of x tends to 0, sine 3x, then you're supposed to have a 3x in the denominator, then it becomes 1. So that's what I have done. I have divided this by 3x, multiplied it with the 3 so that the 3 and the 3 got cancelled, and this x and the x on top there, the denominators got cancelled out. So now finally on top, what do you have? You just have a 1. See, you have a 1. From here you can split the limit. So this is limit of x tends to 0, 1 on top divided by the 3 came out, right? This is limit of x tends to 0, sine 3x divided by 3x. You know the limit can be split into 2 parts, right? Top also, down also. You have learned this also in class 11. Okay, although it's given in like a function form, but while teaching in the question and all, while in the question you will have learned this. Say x tends to 0, f of x divided by g of x if you have. So this limit gets split for both of them. It becomes limit of x tends to 0, f of x divided by limit of x tends to 0, g of x. Okay, so that's what I have done. See, limit of x tends to 0, this is f of x, this is g of x. So as I have given limit to both of them. So this is 1, then it remains 1. Down here it becomes 3 into, this is a 1, so 1 by 3. Okay, let's go on to the right hand limit, RHL. Same thing, limit of x tends to 0 positive, f of x is equal to limit of x tends to 0 positive, x by sine 3x is equal to 1 by 3. Okay, see, 1 by 3 over there, then 1 by 3 here also. You don't have to repeat the same thing over again. Then f of, what is that? 0. So at 0 it's going to become 3. Okay, so you can see the function is discontinuous. The function is discontinuous. Question number 19 part 1, function is discontinuous. Perfectly done. And there is a question number 19 part 2 that's actually looking very interesting. to do, and I want to do it. So let's go on to one more question. I know if you all might be getting bored that continuing and continuing, but one more last question for this video. Looks like a very nice question, that's why I want to do that. Okay, question number 19 part 2, important question. Okay, ISC students, class 12 students, ML Aggarwal, class 12 students, not ML Aggarwal only, class 12 students, whoever you all are studying in class 12, this question is important for you. It's given as sine 2x divided by sine 3x when x is not equal to 0, and it's going to give you the answer as 2 when x is equal to 0, and you have to examine its continuity at x equal to 0. Okay, so let us start this question. It's a simple question. Okay, so start with the LHL, left hand limit. Okay, so limit of x tends to 0 negative, f of x is limit of x tends to 0 negative, which function? That function sine 2x divided by sine 3x. So now what do you have to do? Simple. From here, limit of x tends to 0 negative, this will be sine 2x divided by 2x into 2, and down here sine 3x divided by 3x into 3. See, look, the 2 and the 2 gets cancelled out, the 3 and the 3 gets cancelled out, the x and the x gets cancelled out, we get back the question. Okay, put bracket here, put bracket here. By now you have understood. Okay, from here eventually the 2 by 3 comes out and the limit gets split to the denominator and the numerator. Negative sine 2x divided by 2x. This is limit of x tends to 0 negative, sine 3x divided by 3x. See, simple. This is 2 by 3. This is also 1, this is also 1. So limit x tends to 0 negative, f of x is 2 by 3. Let's go out to the right hand limit. RHL, that's limit of x tends to 0 positive, f of x is equal to limit of x tends to 0 positive, sine 2x divided by sine 3x, the answer is 2 by 3. Okay, and f of 0 is 2. So what happened? The function is discontinuous at x equal to 0. Function is discontinuous at x equal to 0. Right on till 19 part 2. This is 19 part 2. Okay. That was, the previous one was 19 part 1 and this is 19 part 2. Checking the answer. 19 part 2 also discontinuous. That's it for this video, students. Take as much help as possible from my and your channel. Math is possible. See you in the next video. Bye bye.